Hello everyone. In this video, we're going to be solving an interesting exponential equation. Now, this problem was taken from a test for gifted students, and one of my fellow mathematicians on Twitter shared these problems. I'd like to thank him for sharing with us. I'll share all the links down below. He also has a YouTube channel. I'll also share those links down below. So we have the following problem: 2 to the power x minus 3 to the power x equals square root of 6 to the power x minus 9 to the power x. And we're going to be looking for x values. I'll be presenting two methods. Even though the methods are somewhat similar, they have different approaches to the problem, so I would like to present both. So let's start with the first method. And I was also told that I'm not loud enough in the video, so please let me know if you can hear me easily, or you have to put the volume up. Okay, so for our first method, here's what we're going to do. We're going to do some naming. So, substitution is commonly used in math, and that's one of my favorite methods. So I'm going to go ahead and call a equals 2 to the power x and b equals 3 to the power x. Of course, this has some consequences, such as if I multiply a and b together, I get 6 to the power x, and if I square the b, I get 9 to the power x. And the reason why I go with those is because we have them in our expression. Make sense? Awesome. So from here, we get the following. We get a minus b equals the square root of ab minus b squared. Okay. Whenever you see square root, a lot of times our natural tendency is square both sides. So we're going to do the same thing. But sometimes squaring both sides may introduce extraneous roots, so we have to be careful. Okay. First of all, a couple of things to notice. 6 to the power x and 9 to the power x. Isn't 9 to the power x always greater? Well, it's true if x is positive. Or the same thing goes for 2 to the power x minus 3 to the power x. If x is positive, you're going to get a negative quantity, but in the real world, square root of something cannot be negative. Therefore, we want x to be, for this to be valid, x values need to be on a certain interval. At the end, I'm going to show you a graph, and the graph will make it more clear. So let me go ahead and proceed with the solution of this problem. Square both sides. So let's go like this. And then we're going to have a squared minus 2ab plus b squared. And the right-hand side, the square root is just going to disappear. Now notice that we have some like terms. They like each other, right? Negative 2ab and ab. So let's go ahead and put everything on the left-hand side. We get a squared minus 3ab, and then negative b squared. B squared plus b squared, that becomes 2b squared. Uh-oh, we missed the opportunity. To be or not to be. Okay. So now, how do I solve such an equation? Well, I know some of you are like, this is too easy, I can factor, so on and so forth. Let me show you the general method, because these equations are not always factorable. So here's what we're going to do. We're going to divide, and this is a homogeneous equation, by the way, second degree. Divide by b squared. If you divide everything by b squared, notice first of all, if b is 0, then a is also 0, right? But that's not going to give us a good result, because 2 to the power x can never be 0. So a and b cannot be 0. So it's okay to divide by b squared. So let's go ahead and do it. You'll see why we're doing it. It's very meaningful. And of course, it's still 0. Now notice that from here, we're getting a over b quantity squared. Here, b squared and b cancels out, and that gives us 3a over b. And then plus the b squared cancels out. Since it's not 0, we get 2. Okay. Cool. What is so cool about it is that you can use substitution again. Substitution forever, right? So let's go ahead and call a over b. Let's set it equal to u. How about maybe we'll get some 2u somewhere. So now, since a over b is u, we can write this equation as u squared minus 3u plus 2 equals 0. Now, this is factorable definitely, and I can factor it as u minus 1 times u minus 2 equals 0, which implies u equals 1 or u equals 2. But what is u? U is a over b. So let's go ahead and back substitute that. If a over b is 1, that means a is equal to b. Okay, great. What is that supposed to mean? Well, we have the equation. Remember what our naming convention was. We said a equals 2x and b equals not 2x, 2 to the power x, and b equals 3 to the power x. So let's rewrite it here. A equals 2 to the power x, and b equals 3 to the power x. Awesome. Now, what does a equals b mean? It means 2 to the power x equals 3 to the power x. But is that possible at all? Think about it like you have different bases. Well, it's only true if x is equal to 0. So this implies x equals 0. So x equals 0 is a possible solution. The reason why I say possible is because now it might be extraneous. We have to go back and check it. And we'll do that. Now, what happens if a over b is equal to 2? Then from here, if u is equal to 2, u2, 2u, from here we get a equals 2b. Yay! 2b or not 2b. Yay! So now, let's go ahead and replace, use our equation. A is 2 to the power x, and b is 3 to the power x. So we get kind of like a weird equation. How do I solve it, right? Well, there's a couple different ways. You can divide both sides by 2, put the powers on 2 on both sides, put the powers of 2 on one side, and the powers of 3 on the other side, and then you can log both sides. Or you can just put the x terms on one side and use that as a base. So there's a lot of different ways, and there's many possible different answers. So I'm gonna divide both sides by 3 to the power x and write it like this. This is what I prefer. And then this means they have a common exponent. And now at this point, I can go ahead and log both sides. Now, again, you have a lot of freedom here. You can use base 10, you can use e, like ln, you can use base 2/3, so on and so forth. I'll just use ln because ln is really cool. ln, by the way, is natural logarithm, in case you didn't know. So let's ln both sides. From here, we use properties of logarithms. So let's go ahead and move the x to the front. That's what allows us to simplify the process. Like when you ln both sides, you get rid of the exponent, basically, right? So this equals ln2. And obviously, I want to divide both sides by ln 2/3, but let's go ahead and simplify ln 2/3 first. Can I write it as ln2 minus ln3 using properties of logs again? And from here, I can just divide both sides by that and ln2 minus ln3. Now notice that ln3 is greater than ln2, therefore this is a negative value. And that's okay because remember, we had 2 to the power x minus 3 to the power x, and that expression is supposed to be positive, and that's only true if x is less than 0. Cool? Let's go ahead and take a look at the second method. And our second method, like I said earlier, is going to be a little different, but it's going to be simpler, a little bit simpler. So as before, a equals 2 to the power x and b equals 3 to the power x. And we get a minus b equals the square root of ab minus b squared. So far, so good. Same thing. Now, instead of squaring both sides, here's what I'm going to do. I'm going to factor inside the radical. From here, I get a minus b. And then I can go ahead and put everything on the same side, because if I'm trying to solve an equation, it makes sense to put everything on the same side. And then separate these two expressions. So can I write it like this? Square root of b times square root of a minus b equals 0. Now don't cancel out anything. Don't leave stuff on either side. Let's go ahead and factor a minus b. Notice that we have the square root of a minus b. So I can basically write this as square root of a minus b squared, right? And then this expression becomes factorable. And the greatest common factor would be square root of a minus b. And inside the parentheses, we have square root of a minus b minus the square root of b equals 0. So this is how we solve this using the second method. And from here, by using zero product property, such a weird name, we can set each factor equal to 0. From here, we get a equals b. As before, 2 to the x, 3 to the x, and x equals 0. Or we can get square root of a minus b equals the square root of b. And from here, a minus b equals b, and a equals 2b or not 2b. And we get 2 to the x equals 3 to the x times 2. And then as before, we proceed and we get the same answer, which was, let's just go ahead and copy that, ln2 over ln2 minus ln3. I told you that I was going to show you the graph, and this is what the graph looks like. Here we go. I graphed 2 to the power x minus 3 to the power x for u, and the square root of 6 to the x minus 9 to the x. And notice that they intersect at 2 points. One of them is definitely 0, 0, because 0 is going to make this 1 minus 1, which is 0. So 0 is actually not extraneous. I I forgot to check that, but you can see that it is going to work. And the other intersection point, well, if they intersect, that should be a valid solution, right? Anyways, and the other value right here is what I wrote as a comma 2 to the a minus 3 to the power a, but this is the a value. Remember, we found that value, and it's approximately negative 1.70951129135, so on and so forth. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye. Oh.